Hi everyone, welcome to video 2 of section 1.2, more problem solving strategies. So the next example that we're going to do is concerning the strategy of guess, check, and revise. So it's a version of guess and check, which I'm sure you've all heard of, but it adds this third step of revise. So instead of just guessing and checking, and then guessing and checking again, we add this revise step where we think about our guess and think about how we can make it better to get to the answer quicker, instead of just guessing and then guessing again kind of aimlessly. So whenever you use guess, check, and revise, right, we always want to see if there's another strategy first, because this is kind of just blindly stabbing at a question to see if you can get it to work. So we always want to check to see if there's another strategy we can do first. But if we do use this one, we definitely need to write down every guess we make and each revision. So this says as shown in the book. So it should be pretty similar. Your process should be to example 5 on page 17 of the book. So if you haven't looked at that, go back and look at it and see how they do guess, check, and revise, because it should be pretty detailed whenever you do it. So let's go ahead and start this problem. So this example, we have these equations and we have to input the symbols plus, minus, multiply, and divide to make each statement true, right? So we have in part A, 4, 2, and 9, or sorry, 4, 2, and 1, and we need to make that equal to 9 somehow. So let's do our first guess. So for this guess, well, 4, 2, and 1 are all pretty small numbers, and we need to get up to 9. So let's see what happens when we do 4 plus 2 plus 1. So 4 plus 2 is 6, plus 1 equals 7. So 7 does not equal 9, right? So now we need to revise it. So when we revise our guess, we have that 7 is too low. So instead of adding, how can we increase numbers quicker? Is by multiplying, right? Because dividing and subtracting decrease numbers, right? They give us a smaller result. So because 7 is too low, and we've already tried adding, let's try multiplying. So we're going to try multiplying. So now we make a new guess. So for this guess, right, so let's just try multiplying in the first spot, because we could put multiplication in the second spot, but multiplying by 1 just gives us the same answer. So let's try putting multiplication in this first spot and adding in the second spot. So remember our order of operations here. That's really important. Remember that we multiply before we add. So a lot of you have probably seen PEMDAS. So also abbreviated, please excuse my dear Aunt Sally. So remember, we do parentheses and then exponents and then multiplying and then adding, multiplying and dividing and then adding and subtracting. So we're always going to multiply before we add. So this one, 4 times 2 plus 1 is 8 plus 1 is 9. So this one works. It gave us the thing we wanted, so that gets a check mark. And we input our 2 symbols here, multiplying and adding. So these are our solutions. So we multiply and then we add. Okay, so let's go to part B. So again, let's just do a guess. So we have 6, 2, and 5, and we need to get to 8. So I don't know, 6, 2, and 5, they're not as big as 8, but they're pretty big. So let's try some combination of adding and subtracting. So let's guess 6 minus 2 plus 5. right? Add and subtract because the numbers are all around the same size. Okay, so 6 minus 2 plus 5. Well, that's going to give us 4 plus 5, which is 9. So it's really close to 8, but it's not quite there. So we're going to revise it. So 9 is too high. So what are we going to do instead? Well, 9 is too high. And so if instead of adding, we multiply, that's going to give us something that's too big. But let's, instead of subtracting, let's try dividing. So let's going to try dividing. So make that subtraction sign and the division sign, because we know that 6 divides evenly into 2 parts. Okay, so our guess here is we're going to do 6 divided by 2 plus 5. And now we're going to check it to see, again, we multiply and divide before we add and subtract. So 6 divided by 2 is 3. Plus 5 is 8, and that is correct. So that gets a check mark, and we can put this in our answer. So we have 6 divided by 2 plus 5 equals 8. Okay, great. So now we're going to do this last one. So 7, 3, and 2. So 7 is bigger than 6, and 3 and 2 are smaller than 6. So kind of like part B, let's try a combination of adding and subtracting. So we're going to guess 7 plus 3 minus 2. And when we check it, 7 plus 3 is 10. Minus 2 is 8. So 8's not 6. And we actually see in our revision that 8 is too high. So we could try, right, dividing at some point, but 7 isn't divisible by 3, and 3 isn't divisible by 2, right? And so if we're changing from subtracting to division to get a smaller number, well, that won't work because we don't have things that divide evenly here. So instead, let's try a different strategy. So we know we want to add, we want to increase some things and decrease some things. So we want to try, instead of switching to division, we want to try switching our pluses and minuses. Okay, so now we make our second guess where we switch the plus and the minus. So now we do 7 minus 3 plus 2. And when we check it, we get 4 plus 2, which is 6, which is exactly what we're looking for. So now we input that up here, and we have done all of these problems. So this is an example of guessing, checking, and revising. So these, we only had to do 2 guesses and then we got it. So definitely check out the textbook number 17 to see a longer example of guess, check, and revise. There weren't a lot of options of how to get the right answer, so we got it pretty quickly. Okay, so the last strategy we're going to go over is working backwards. So yeah, working backwards. This should say example 3. Okay, so working backwards. So this one is covered on page 15 of the textbook. So we're going to go through this one. So this says, at the end of the day, you have $18. You remember taking $15 out of the bank, spending $5 on lunch, and $21 on a new phone case. How much money did you have at the beginning of the day? So this one, you can tell that it's a working backwards problem because the first sentence, the first phrase in the question is talking about the end of the day. And it's asking about the beginning of the day. So working backwards is a strategy that makes a lot of sense here based off of the words in the question, right? With those problem-solving strategies, the first thing to do is understand what it's asking. we're given information about the end of something and need to get to the beginning of something, that's a pretty good indication that the strategy we're going to use is working backwards. Okay, so let's do this problem. So at the end of the day, we have $18. So we remember taking $15 out of the bank, spending $5 on lunch, and spending $21 on a new phone case. Okay, so to organize this, I'm going to put it in a table of the transaction history. Okay, so we're going to make a table that has the event that occurred and the dollar amount. So at the end of the day, we had $18. So before that, we took $15 out of the bank. So when we went to the bank, we took $15 out of our account, which means that before we went to the bank, we only had $3 because we increased our money by 15 when we withdrew $15 from the bank. So when we got to the bank, we had $3. Okay, what happened at lunchtime? So at lunchtime, we spent $5 on lunch. So that means that before we got to lunch, we had $3 plus those $5 of $8. Okay, what else happened? We also got that new phone case. So when we got the new phone case, before we got the new phone case, we had $21 more, which means that we had $29. So that tells us that this, since that's all that happened, right? We took the money out of the bank, we spent the money on lunch, and we spent the money on the phone case. So those are the three things that happened, which tells us that at the beginning of the day, we had $29. When we got $15, or sorry, when we took money out of the bank, we then had 29 plus 15, which is 44. We had $44 when we ate lunch. We then had $39, and when we bought the phone case, we had 39 minus 21, which is $18, which is what we had at the end of the day. So writing this little explanation also helps us verify our answer to see, well, if that is what we started with, then do we end up with the correct things at the very end? So this, writing our explanation, is kind of our looking back. So it's our fourth step in the problem-solving strategy of looking back and making sure everything makes sense, is kind of this written explanation I had to just make sure that our answer was correct and it all made sense with the information that we had. Okay, so that is the last example for section 1.2. So now you should have everything that you need to go ahead and complete the section 1.2 homework. So like always, if you have any questions on anything in the book, in these videos, or in the homework, definitely always email me or come to office hours so we can talk about it. So that is all for this video.